Here we have AP calculus AB problem. Okay, let's go to the question. If f of x equals to 3x cube negative x positive 4, then f inverse prime of 6 equals to. That is, we have to evaluate the value of the derivative of the inverse of f of x at x equals to 6. Okay, so to get the derivative of inverse of the function f of x, there is a formula. Let me write the inverse of f of x, that is the f inverse of x. Now, let me get derivative for this one. So the formula is we have to write 1 in numerator. In denominator, we have to take f prime of f inverse of x. Okay, since our aim is to find the value of the derivative of f inverse of x at x equals to 6, we have to plug in 6 for x over here and here. Let me do it. Then I'm getting f inverse of 6 prime equals to 1 over f prime of f inverse of 6. Okay, here the stuff f inverse of 6 prime and f inverse prime of 6, both of them are same. Okay, now to get the value of this one, first we have to get the value of f inverse of 6. How do we have to get the value of f inverse of 6? For that, let me consider the two sets, set A and set B. And let's say the function f of x maps the elements from set A to set B. Okay, let's say a is lowercase a is an element in set A and lowercase b is an element in set B. And now when I plug in x equals to a, that is here, since f of x represents a mapping from a to b, so the input value of x over here must be the elements of a. Now let me take the element lowercase a in set A and I just plugged in as input over here. So what is the output? Let's say that this lowercase a has been mapped to the element b. Then b is the output of when x equals to a, that is the b is the result of f of a. Okay, now let me consider the inverse of this function f of x, that is the f inverse of x. Okay, when f of x maps the element from a to b, then f inverse of x will map the elements in the reverse order, that is b to a, and here the input values of x must be the elements of set b. So now let me consider the element lowercase b in set b. So let me take this lowercase b as an input over here in the inverse function. Then I'm getting f inverse of lowercase b. So the output has to be in the set A. Already we know that the output is a because the a is lowercase a is mapped to b, lowercase b in set b. Then this lowercase b will be mapped to lowercase a in set a. So then f inverse of b is equal to the output is a. Okay, now the same logic we can do with the number what we have over here, 6. Okay, now let me erase the stuff over here. Okay, so our aim is to find the value of f inverse of 6. So now let me erase this b over here, 6. So now 6 is the input for inverse function. As I said already, always the input value of x must be the elements of b. So here 6 is the input value in this inverse function. So the 6 has to be in the set B. So what should be the output? Let's say the output is k. That is 6 is mapped to k. Then f inverse of 6 equals to k. Then what is f of k? So clearly k is mapped to 6. Then f of k equals to 6. Okay, now we have to use this equation and solve for k. So when I get the value of k, so that's the value of f inverse of 6. I can plug in that value over here and I can evaluate the value of this expression. Okay, now let's solve for k in this equation. For that, what we have to do is we have to plug in k for x over here. When I do so, I am getting f of k. On the right side, we get 3k cube negative k positive 4. So this is a stuff is equal to f of k. So we can plug in that one over here for f of k. That is 3k cube negative k positive 4 equals to 6. Okay, now let's subtract 6 from both sides. When I do so, this positive 6, negative 6 will cancel. I'm getting 3k cube negative k. When I combine positive 4 and negative 6, I'm getting negative 2 equals to 0. Okay, here we have a cubic equation. Now let's solve this cubic equation using synthetic division. Okay, let me write over here. Now let me consider the coefficients of the terms over here in this expression. The coefficient of k cube is 3. Let me write it. After k cube, we must have the term k square, but we don't have k square in this expression. So for that, we have to write the coefficient 0. Now let's write the coefficient of k, that is negative 1. The constant term is negative 2. And now I have to write 0 here. We have to add this 3 and 0. I am getting 3. Okay, now I have to do trial and error to get solution for this cubic equation. So now I have to try whether this 1 can be the solution. That is, this 1 can be the value of k in this cubic equation. So let me write 1 over here. We have to multiply this 3 and 1. 3 times 1 is 3. Now we have to add this 0 on 3. 0 positive 3 is 3. Now this 3 has to be multiplied by this 1. 3 times 1 is 3. Now when I add negative 1 and positive 3, I am getting 2. Now I have to multiply this 2 and 1. 2 times 1 is 2. Negative 2 positive 2, that will become 0. Even my first trial is success. So because I got 0 over here. So that is this 1 is a solution of this cubic equation. So because I get 0 at the last. In case I don't get 0, what should I do? So I'm out to try negative 1. If it doesn't work, I'm out to 2, negative 2, 3, negative 3. In this way, I have to keep on trying until I get 0. Okay, so when I tried whether this 1 can be the value of k in this cubic equation, I got 0 at the end, that is remainder. Okay, so 1 is one of the values of k, because since it's a cubic equation, we may have 3 values for k. So I got one of the values of k, that is k equals to 1. Okay, now what we have done is we have to write another equation using these numbers as coefficients. Since we have started with cubic equation, so the equation that I am going to write over here with these numbers as coefficient must be having the degree 1 less than the equation we started with. So the degree means the largest exponent of k, that is 3. So here the equation I am going to write must be quadratic equation, because for quadratic equation the degree is 2, which is 1 less than the degree of the cubic equation. So then this 3 must be the coefficient of k square, this 3 must be the coefficient of k, and this 2 must be the constant term, equals to 0. Okay, now we have to solve this quadratic equation. Solving this quadratic equation, there is a chance to get 2 values for k. But I don't think this quadratic equation can be solved by factoring, because to solve this one by factoring, we have to multiply the constant term 2 by the coefficient of k square 3. In that case, I am getting positive 6. So I have to get 2 factors over here, so that the product of 2 factors equals to positive 6. When I add these 2 factors, that must be equal to the coefficient of k. I don't think I will be getting such 2 factors. So we may have to use quadratic formula, but before that, we can check whether we can have real values as a solution for this quadratic equation. For that, we have to get the value of the discriminant b square negative 4ac. So here the b is the coefficient of k, that is 3. We can write 3 square negative 4 times. The value of a is the leading coefficient, that is the value, coefficient of k square. And c, the constant term is 2. Let me plug in. So when I do so, 3 square is 9, negative 4 times 3 is 12, 12 times 3 is 24. And 9 negative 24 is negative 15. Okay, here I got the value of the discriminant b square negative 4ac. Its value is negative 15. In a quadratic equation, if the value of the discriminant b square negative 4ac is negative, then we will not have real solutions for the quadratic equation. Okay, so for this cubic equation, we'll have only one real solution, that is k equals to 1. Already we got it. And k is the value of f inverse of 6. Now we got that k equals to 1. Therefore, the value of this f inverse of 6 is 1. We can plug in this 1 for this f inverse of 6 and evaluate the value of this expression. Okay, now let me erase this stuff and continue the problem. Now let's plug in 1 for this f inverse of 6. Then I'm getting 1 over f prime of 1. Okay, now we have to get the value of f prime of 1. For that, we have to get the derivative of the given function f of x, that is f prime of x. Once we get the f prime of x, we have to plug in 1 for x. Okay, now let me take the given function as it is. That is f of x equals to 3 times x cube negative x positive 4. Okay, now let me get the derivative of this function f of x, and I'm getting f prime of x. Here 3 is a constant multiplied by the variable. When I find derivative, I have to keep the constant which is multiplied by the variable as it is. Okay, now let's get the derivative of this x cube by using the power law of derivative. That is, we have to bring the exponent 3 in front of the variable and subtract 1 from the exponent negative. The derivative of x with respect to x is just 1, and the derivative of this constant is 0. Okay, then we get f prime of x equals to 3 times 3 is 9. 9 times x square negative 1, and we can skip this 0. Okay, our aim is to get the value of f prime of 1. That is, we have to plug in 1 for x over here. Then I'm getting f prime of 1 equals to, on the right side also I have to plug in 1 for x. Then I'm getting 9 times 1 square negative 1. Then f prime of 1 equals to, the value of 1 square is just 1. 1 times 9 is 9 negative 1. F prime of 1 is equal to 9 negative 1 is 8. Okay, I got the value of f prime of 1, that is 8. Okay, let me plug in 8 for this f prime of 1, then I'm getting 1 over 8. Okay, I got the value of f inverse prime of 6, its value is 1 over 8. We find this 1 over 8 in answer choice A. The correct answer choice for this question is A.